Hi everyone. I'd like to welcome you to today's presentation where we will be looking at the BIM 360 platform, and I'll be doing an overview and how it can help us with our civil projects. My name is Jerry Bartels and I'm a senior technical sales specialist primarily focusing in infrastructure here at Autodesk. As a brief agenda, what we'll be covering today is we'll be doing an overview that's going to focus on different ways that BIM 360 can help us, including reducing the need for paper plans, increasing the value of the electronic prints or the PDFs that we create, providing anywhere, anytime access to our files within the cloud, improving the way that we share and exchange files, doing design model collaboration, and more. We'll do this through a workflow demonstration that'll show the different tools within the BIM 360 platform working together. We'll end with a summary and then take your questions. My goal for the session is to give you some exposure to the BIM 360 platform. We'll review a subset of its capabilities. It's a complete end-to-end solution. We're going to be looking at it from just through the lens of how we will use it on a civil project, primarily through design, but would also help us in some of the areas pre-design, also getting into pre-construction all the way through completed construction. So as we go through, I want you to understand the business benefits and how they can help us today, and then as always address any questions that may come up along the way. So let's go ahead and get started. So when it comes to BIM 360, the reason it's going to be important for us today is we're talking about it through the lens of collaboration. Some of the challenges that we have in traditional collaboration is we're usually working in an office, and in that office we're working on a project that is in some relationship further away from the office. So as we work on that project, it's not usually just us that's working on it. There'll be other folks as well, perhaps maybe a second office. Maybe there'll be sub-consultants. Maybe we've got other folks that are participating in review. Maybe we have somebody else from the city. There'll be a number of individuals that will need to collaborate and be an effective participant on that project. To do something like that and do it well requires the ability to collaborate and collaborate effectively. So to facilitate this, Autodesk has created a cloud-based solution that's going to help connect people and data, and that solution is the BIM 360 platform. Now in the BIM 360 platform, the core of the platform itself is BIM 360 docs, and what the docs are is that's where our files are stored. That's where we're going to create users, manage permissions. That's going to be the versioning of our files. We've got a audit tracking that we can determine different transactions that take place within the project. We can look at issues to track that critical things are not only assigned, but there are worked through to completion. We can facilitate communication. It's the core of the application that everything else is built on top of. From there are additional modules that help build out some of that functionality to allow us to do more with the BIM 360 platform. One of those modules is BIM 360 Design. Using design truly from a civil perspective, that's what's going to allow us to work on a civil 3D project in the cloud. It's going to let us create data shortcuts and references as we would traditionally do on a shared network drive or in a local office type of space, and it's going to allow us to do that work in the cloud. That's also the same tool that many of our friends on the architectural side have been using with their Revit to work on architectural projects in the cloud. Now that functionality has recently been expanded or extended to support civil 3D projects as well. There's another module here for BIM 360 coordination. What that allows us to do is aggregate models together, because a project may not just be the civil components. It may be civil and architectural, and it could be utilities and other model components together to bring together like a complete version of the project that oversees or works with a number of different disciplines. The coordinate tools would allow us to aggregate that model and then start to run some analysis against that for looking for whether things can be built the way that it was designed, if there are clashes or anything that needs to be resolved. The other module we'll talk about is the build module. With build, it helps facilitate field coordination. In the build module, we would use it for doing things like checklists as part of a QA/QC process, maybe doing some type of an audit on the work that's being done. For doing site visits, things like that, the the tools within the build module will help us quite a bit. The entire BIM 360 platform is built on top of Autodesk Forge, which is a series of APIs or programming interfaces that let us interact directly with the information that's stored in BIM 360. So what this does is it empowers our end users to create tools that can connect to the BIM 360 cloud and perform analysis, generate dashboards, run reports. Basically empowers our end users to extend the functionality of what comes out of the box and allows them to create new tools that are specific to their needs without necessarily having to wait for Autodesk to create something for them. So understanding that, what I'd like to do is we'll step back and we'll see how all of these tools can be used together with all the different folks that may be interacting with the project. So to facilitate this communication, what we're going to do is we're going to look at it through an example workflow and the number of folks that might be part of a particular project and how those folks might work together. So when we start, we're going to look at it from maybe where the project starts at the level where data is collected by a surveyor. It's then going to move through, the design is going to be done by the engineer or series of engineers. That information could be reviewed by a BIM or a project manager as part of that process. If they are the only ones that are part of the project, from there it could be, once it's approved, sent right out to the customer. If they are going to be working as part of a team with other external consultants or team members, these could be architects, landscape architects, other consultants, then their data, the models that they create and the information will be merged with the other consultants' data, and that'll be reviewed by a project coordinator that will aggregate, bring all of that model together to create a complete representation of the project, resolve any issues, and then ultimately it would go out to the client. Along the way, there will be other folks that will be interacting with the project, and we'll look at different ways that BIM 360 can address those folks' needs. Okay, so understanding that, let's start at the top, and we'll look at it from a perspective of if we're a surveyor. The first thing that we're going to do is we're going to create a topo and then share that topo in Civil 3D with the next people in line, which would be the engineering group that would rely on that topography. So if we look at that first, we see with BIM 360 installed and the Autodesk Desktop Connector, we've got, in a sense, like a new drive letter, BIM 360. From there, we can drill down to our account. In this case, it's Wayne Enterprises, and then directly to our project, State Route 25. Once we look at that, a series of folders have been created on our machine using Desktop Connector, and then in the Prospector tab, we can see that those folders are mapped to a BIM 360 project that exists in the cloud. So as a surveyor, let's go ahead and start building a surface. In this case, we'll build it from points. We'll bring the points in. We can see those points represent the ground. That information looks good. Let's go ahead and create our surface. We'll give the surface a name, associate a style with it. We've got our surface, and we're at a point now where we're ready to share. So using the same workflow that we would have done in the past, we'll go ahead and save our drawing. However, this time, the Autodesk Desktop Connector is going to see that the file was saved on our machine, and it's automatically going to sync that file with BIM 360 in the cloud. From there, we're going to come down and we're going to make sure that the file is associated with our project, and it is. And then the next thing that we're going to do is we're going to take our surface and we're going to create a data shortcut. Now, one of the great things about this process is, from a truly Civil 3D perspective, the workflows that we use are going to be almost exactly the same as the workflows that we've used traditionally when sharing a project using a local or a shared network drive. So our data shortcut has been created. We see it's available for us now up in the cloud. If we were to come out to BIM 360, we can see the drawing, and it was saved by the surveyor. I have the ability that I can click directly on the drawing, and without any authoring application, just using the web browser interface for BIM 360, I'm able to view the drawing the same way that the engineer would. I'm also able to drill down, and I can see the permissions that can be assigned to those individuals. In this case, the surveyor's got the most permissions, the engineer's got the least, and the project manager is somewhere in between. I can also see that from a surveyor's perspective, they don't have complete access over the project. We can see that just by looking at the project folders area, they don't currently have permissions assigned to that. So using BIM 360, we can assign just the right permissions to the different areas of the projects that folks need to interact with. Next, we'll drill down and we'll look at it from the perspective of the data shortcut has been created, and we'll look at the process of what's involved in creating a model. So from the engineer's vantage point, they're in Civil 3D now. They're going to leverage the data reference or the data shortcut that was created by the surveyor to automatically pull that surface in from the cloud. So they'll assign a style to that to represent it in their model the way that they would like to see it. And then there may be other engineers or other folks working on the project that have created data shortcuts that they can take advantage of as well. So they'll go ahead and bring those into their file and then start to build out their complete corridor model. Once the model's complete, they've got their grading, they've got it displayed correctly, they've got their annotation. If they'd like to add some maybe utilities from an X-reference file, those could be X-reference from BIM 360 as well. In this case, that would be our water, sanitary, sewer, and maybe the culverts under the streets. And then once that corridor has been created, they could even create a data shortcut themselves to the corridor model that somebody else downstream in the project may want to take advantage of that as well. Now, once that's been saved, in this case, the engineer has not physically gotten out of the file. What we can see in BIM 360 is there's a lock next to the model that they're in, indicating that it's locked for editing by them. Which means no one else could be able to, they could open the file to make changes. But by the same token, you could click in BIM 360 into that file and see the current status, if you have rights to it, as far as where the engineer is currently with the last save. All right, so using that tool, we're able to have multiple people working in the projects. We've got file locking that's going to control access to make sure that no one steps on top of each other. Now, we'd like to think that once the engineer did that work, that was it, everything would be fantastic, but working on that model is generally going to be an iterative process, back and forth between them and usually a project manager or someone else in the office that they'll be working with. So, and as they're reviewing things, it may be models, it may still be electronic prints like PDFs. Let's take a look at a little bit of what that process looks like reviewing both a PDF or a model. So in this case, the project manager is going to be looking at a PDF that was maybe created by the engineer. So they can drill in, see the electronic print. Using the BIM 360 interface, they can move around this large format sheet. They can see that I've got contour labels, lot numbers, annotation. I've got the appropriate utilities in that displayed in my profile. However, I do notice that I've got some annotation pointing to some sewer laterals, and the actual geometry itself isn't being displayed. So I've got tools within the interface that as a project manager, I'm going to mark that up so that that can get addressed. I can mark things up in different colors based on maybe different disciplines who will be addressing it. Maybe I want to come up with a strategy that I've got markups, different colors for different people. Those markups can be set up as private or public. Maybe they're markups specifically to me, or I'd like to make them public because I'd like to have somebody else be able to see them to go through and address what needs to be corrected. Now what I want to do is once the markup's complete, I'm going to create an issue. And with that issue, I can track that markup through to completion. So I'll assign an issue. I'll assign it to a particular individual, in this case the engineer. I'll give them a date of when I'd like to see that completed. And then I can associate some other information like a root cause and an issue type that I may want to filter on later. We'll give some description of what I'd like to have done, and that issue has been created. Looking at it from the same perspective, we could also mark up models. In this case, I'm looking at a model that's got a number of utilities and some road geometry. Having a model makes looking at the utilities, what goes over and under other utilities, much easier to see and discern. Much the same way that I would have within a PDF file. I could take measurements, maybe if there wasn't measurements listed. In this case, I can see the road is 31 foot wide. If I'd like to maybe get a vertical distance, maybe from the bottom of the light to the pavement, to get an idea of clearance, because I'm working in a model, I can do that as well. So as I move around, there's intelligent grips that tell me that the vertical distance and the Z elevation in this case is 13.9 foot of clearance from the bottom of the light down to the roadway. Now in this case, I see there's something in the design that needs to be addressed. I've got some pipes that obviously don't have enough cover in that particular location, so I can construct another issue assign that to the appropriate individual, and then provide a description as well. Once those are created, the engineer will receive emails for every issue that was created. They can also review the issues from within the project, but the emails help facilitate some of that communication. Once they go into the issue themselves, they can look at it. They've got links that go directly to the file that then they can see what was marked up and what was left for them to address. So in this case, Ava, our engineer, has opened that up. They see the issue that was tagged here, and they can come down and review what was set up for them. They'd like to make sure that the laterals are restored. So that's been responded to and then answered. That information will then go back to the project manager. Without going back to the email, they can see that the issues that are associated with them can be filtered and displayed directly within the project. So she can come in and make a similar response for that information that makes up the model. So whether it's a PDF or a model, that process of the back and forth can be facilitated between a civil engineer and a project manager such that the model itself gets completed. Now, once that model is done, there's going to be probably a review process or something that needs to happen before it leaves the office. In this case, what we're going to do is we're going to submit that for an approval so that there's a record of what's reviewed, and we make sure that the appropriate people look at what needs to go outside the office. So we're going to have the engineer now use the BIM 360 platform as part of that approval. So first thing, the project manager is going to set up a review process. This is something that's completely customizable. So they're going to set up a road design approval process. They're going to give it a description. This can be a single point review. It could be a multi-point review. The initiator in this case is going to be the engineer, and it's going to be something simple. It's just going to go to the project manager. We can set up different approval status. That's totally customizable. And then once it's finished, if it is being approved, generally we're going to put it into a folder and make it available to somebody, so that we'll set it up to automatically do that as well. So once it's approved, it automatically copies it to the appropriate folder. So in this case, the engineer is going to export the corridor model as solid objects so that we're not dealing with, civil 3D objects. In this case, that was what was requested for the construction aspect. They just wanted solid objects for the model. So she's exporting those corridor solids to a separate drawing called Road Design for Construction. Once those have been exported, that can also be supplemented with other information. In this case, the utilities, the culverts, the water main, the sanitary sewer. And the file itself, we see that's up into the cloud. It's ready to be submitted for review. So she's going to leverage the review process that was created by the project manager. And we'll come down and we'll look at the one file that's going to go out. Now, this doesn't have to be models. This can be any information that's part of the project. So maybe she's submitting a PDF for review. Somebody's going to review it before it leaves the office. We can select what's appropriate. We'll come down and give it some notes here at the bottom to help facilitate that communication. In this case, please review for the other trades that'll be working on this part of the project. We'll submit that. It'll notify the reviewer. If there are other people that need to be kept in the loop, those folks can be added as well. It can add separate messages. Lots of tools within BIM 360 to help facilitate that communication, make sure everybody's kept in the loop. All right, now once it's submitted for approval, the next place we're going to go is down to the project manager. They're actually going to perform the approval. So let's see what that looks like. First thing they're going to do is they're going to receive an email that said that the submittal was sent to them. They can get some details about that submittal, and then they can click on the button to go ahead and view the review itself. It'll automatically take them to that portion of BIM 360 where they can perform the review. They see the two files that have been submitted, a PDF and the DWG file itself. So they'll go ahead and start the review. And if you look on the right side of the screen, there's the progress. It maintains an audit trail of who's doing what. It says that it was submitted by the engineer. It's now currently being reviewed, or the process where it is being reviewed by the project manager. It can take and view the model in Civil 3D, both in 2D or 3D. Now, depending on what it is that they're reviewing or how they'd like to review it, they can view things visually. They also have, like the tools we saw before, they can measure distances, Maybe I'd like to know the width of the lane. In this case, it's 13 feet. If I'd like to know the information about or distances the head wall, I can see it's 6 foot high, maybe 10.5 foot long. And because I'm in a Civil 3D model itself, using the BIM 360 interface, I can click on the different civil components of the model, and we can drill down and get property information, such as the structure name. We can get size, we can get rims, we can inverts, we can get connected pipes. We can get all types of information about the structure itself, because we're literally reaching in and pulling information right out of the Civil 3D file. So in this particular case, that model looks good. We can perform a similar review on the PDF. So in this case, using the process they would look at, do I have my annotation? Are all my contours labeled? My lot numbers? Is everything legible? Is my profile called out correctly? Is the material and the slopes of my utilities shown? Do I have the riprap and the other soil erosion protection documented correctly? Do I have everything in the title bar, the title block of my plan sheets done? If need be, I could create markups or create issues just like we looked at before. In this particular case, everything looks good, so we're just going to set the status for each of them to approved. Once that's approved, we'll go ahead and submit the review. And like we talked about before, at the last part of this stage, it's automatically going to copy those files to a separate folder and make them available to whoever is next in line to receive it. So those files will get exported, the progress is updated on the side, and if we'd like to go into the folder to verify that those files are there, we'll drill into that particular folder within the BIM 360 project. We see both of those files are now ready for the next person who's going to work with those. Now, sometimes at approval process, we've been in a lot of different offices, those folks have regimented like audit processes that they want to make sure that it's not just a visual. They want to remember, you got to check this, you got to check that. Well, using some of the tools in BIM 360, we can use a checklist to help facilitate that QA QC process. And that checklist could be run on a phone, a tablet, it could be run on another desktop, another screen. What we could do is in that checklist, drill into that application and then use that to help facilitate a regimented review. So I'm going to open up my checklist. In this case, I can see that there's 6 sections that I'm going to be reviewing. And we'll start with the first portion here. Does the plan include a north arrow? Yes, no, not applicable. We can start to fill out this customizable checklist, make sure my text is all greater than 10 point. Is there a graphical scale? All right, all of that looks good. Then we can get down, we start talking about some of the design information. Are all the pipes and materials labeled? Well, in this case, I've got a concern. So I'm going to select notes, and using the voice to text recognition, I can, rather than typing it in with my thumbs, I can just dictate and it will put that information in for me. So it adds that directly to my checklist. I can add a photograph to help supplement that. And the cool thing about a photograph is it extends this functionality of the QA, QC, or the audit process, not to just electronic prints like PDFs, but even to paper documents as well. So I could take a photograph off a paper print to show the area that I've got concerns with. So in this particular case, are all the pipes and inverts materials labeled? I'm going to say no. Once that's done, back in the project, we can drill in and see the completed checklist. We can review the different subsections to make sure that everything was completed. We can scroll down and we can see any supplemental information that was added, notes or photographs. So that is our completed record that the audit was done. And then if we want something that we can send back to the person who requested the submittal, we can export a PDF report. And as far as or requested the approval or requested somebody review it, what we could do is we could see from that report now that it was completed, when it was created, when it was scheduled, when it was done, who did it. We see all the responses as part of that, including any photographs or notes that were part of that process. So for those organizations that have a more of a regimented audit QA QC process, BIM 360 presents a nice tool that helps facilitate that approval. All right. If, once again, like I said when we started, if these were the only folks working on our project and then it was going to the client, once it's approved, we would send it right to the client. If we're working with a larger group that includes external team members or sub-consultants, these could be architects, these could be landscape architects. In my case, The external team member happens to be someone who's doing an electrical conduit as part of the project. So our group has completed what they need to. They've passed it on to this point in the process. The other folks are going through a similar process themselves, and they're going to supplement their information or submit it, and then we'll aggregate it from there. So let's take a quick look at this. When our external consultant is going to submit their data, they're going to log in to their BIM 360 account. If they were tied to the project with a desktop connector, they would just save it in the folder and it would be done. To show you a couple different ways and the flexibility that we can have in the BIM 360 environment, what we can do is we can set up a folder that is unique to this individual or this firm, and anything they put in that folder would then go into the project. So it doesn't necessarily have to be saved out of Civil 3D. It could just be dragged and dropped, the data that they want to contribute to the project, and once it's dropped into that folder, it's ready to go by the other people who are going to be working with the project. So in this case, Evan has dropped that into the folder, made that available to the other people who will be utilizing the data further on down the line. All right, so we've now got the data from one firm, a second firm, and maybe 5 or 6 or 3 or however many other ones. From there, what we want to do is we want to aggregate all of those models together. We're going to assign that task to someone who's going to perform a BIM coordinator or project coordinator role. They're going to bring all of those models together and then start performing some analysis to make sure that there aren't clashes and that it can be constructed in the field as it's intended in the design. So what we'll do in this case, let's see what their workflow looks like. So in this particular case, the project manager, before the sub-consultant submitted the file, they had subscribed to this folder. The great part about that is in that utility folder, because they've subscribed to it, as soon as the consultant put it in that folder, they immediately got an email that said, hey, this conduit file was just put there. Our project manager or a project manager could review that. That looks good, go through their own approval process, submit it then for the coordinator. Carl is our coordinator. They're going to log into the project. They've got their own rights and permissions to the different aspects of the project. So when they log in, they're going to see the folders that they have rights to. So it's the area of the project where things have been set aside specifically for them. So if we look at the utility area, we've got the conduit available for construction. We've got the road design for construction. We've got grading. In this particular case, we're going to use Navisworks, and we're going to bring in the road and the utilities. After the road and the utilities are in, we're going to supplement the data that makes up the electrical conduit. So we see that appear, and then we would continue to fold in other data from other folks who are participating in the project and have submitted models. Once the project has been aggregated, all the data has been brought in together, we're going to create a clash analysis on that. We're going to assign it a name. In this case, I'll give it the same name as the consultant. From there, I'm going to come down. We're going to compare their data to make sure to see if there's any problems or conflicts with the head wall, storm sanitary, or water. So I'll select both of those I'd like to compare. I want to know if they're within a foot. Anything within a foot I'm going to be concerned about. We could also just do a hard clash to see if things run into each other. I see in my case that there are 3 instances where we have a problem. The conduit is hitting both head walls. And the third clash, we can see that there must be a proximity problem with how close the water main is to the conduit. And we look at the list here, it's within a foot. It's about 7/10. From here, we can run a report that will provide some specifics back to the people that need to address these changes. So it'll show all the different clashes. It'll give the coordinates of where the clashes are located. It'll tell specifically what utility is conflicting with what. As I'm going to report this back to the project, we're going to use issues like we looked at before in BIM 360. Because 2 of them kind of involve the same thing, I'm going to group those together as a single clash. And then I'm going to use a BIM 360 issue app in Navisworks to create that issue. So same thing we did in the regular BIM 360. I'll bring up a dialog, we'll create an issue, and then drop a push pin. The type of issue we have here is a design problem. And the conduit is interfering with the head walls. I can set it up that we need to get something addressed by Evan, the one who created the conduit. I can assign a root cause of constructability. and then I can provide a description. Once again, some of these values like root cause and things like that, they're not required, but they can be fantastic tools that we can use to filter on these issues later. Throughout the course of a project, we can run into a lot of issues. Being able to filter them by different categories, we can report on them then separately in different groups can be very helpful. So we'll continue to create the second issue here regarding the water main. I'm going to intentionally not fill out a couple of these values as well, specifically like when I want them completed, because I may not always know that information as I do it. So what I want to show you is we'll create the issues. Once the issues have been created, I can drill back into the issues and modify them. We can add attachments, for example, like we created that report. So I'm going to add the reports so that when Evan views these issues, he has the complete report that gives all the detailed information we saw before. I'm then going to go back into, as the coordinator, into BIM 360, and I'm going to filter my issues based on those things that are going back to Evan. Comes down to the two that we created. You notice we didn't add a due date to it. I also didn't put in a constructability for one of them. But I can drill back into that and I can update those because I'm the owner, or the coordinator is the owner of those particular issues. So we'll update the one, and then we'll update the other one with constructability and the due date. Now the great part about this, some folks may be thinking, ooh, if someone's going to be changing dates, that could be a problem. How do we know that dates weren't changed after the fact or something like that? Remember that BIM 360 is going to facilitate communication amongst these individuals. So now that that's done, it's going to go back to Evan, and let's see what type of information he receives. Basically, if he can resolve the issue, he will do that, send it back through the system. If it's good, we can send it out to the customer. If not, then he's going to have to request information back through the folks that will be able to answer that question. So from Evan's perspective, we see that not only did he receive emails assigning those issues to him, but also received emails when there was things changed. All right, so that information or that communication is facilitated as well. So using that email, can go in and view the issue. In this particular case, going to view the issue, see the information that's been added. The conduit's too close to the water main. Going to go ahead and select the model to be able to view that. And the model will come up. We'll see the push pins, the same as what was put in by the coordinator. So the conduit's too close to the water main. When he selects the other one, we'll also see that it interferes with the head walls. That needs to be addressed as well. Much like we saw before, Evan has the ability to drill into attachments or activity to see if there's any other data that's available. The head walls, we didn't assign it to that one, but in the one for the water main, we see all of the pertinent information that came out of Navisworks in that report that we attached. We can see the activity, when it was created, when it was uploaded, what was set or what was modified, so we can always go back and track from its origination through where it is currently. So in this particular case, Evan wants to resolve it by lowering the water main, but he needs to get permission, ask a question if that's going to be good to go under the head walls. So he's going to create an RFI, or a request for information. So he's given it a title. He's going to send that back to the project manager at the engineering firm that controls the head wall. He's going to give him a date of when he'd like to see that back, and then he's going to enter his question. Essentially, can the conduit be installed under the head wall? All right, he can put in things like a suggested answer. He can attach a document to help facilitate an understanding of specifically what he's asking. So he's going to go ahead and use the model that he's been using so far. And in this particular case, he can drop a push pin for the RFI in the location he'd like him to review. So we're going to put one in the proximity of the area for all three conflicts. He can assign cost or scheduling impact information, talk about priority, lots of stuff that can be filled in. He can put in a distribution list if other people need to be notified. Lots of tools to help make sure that everybody's kept in the loop. All right, so in this particular case, he's created the RFI. That's been sent off, and it's gone back to the project manager at the engineering firm. So we'll come back and look. The ball's now in the project manager's court. Let's see what that looks like from their perspective. They receive an email That email indicates that an RFI has been sent to them by the people working with the electrical conduit. Going to go ahead and view that RFI to see what the details of the information that's been entered. So he's going to scroll down the list, see it was assigned, can the conduit be installed under the head wall. He's going to go in and look at the model itself to get an idea of where specifically this concern is. Because ultimately, the project manager may not be the one that can answer the details of this particular question, may want to route it back to somebody else within the organization. So in this particular case, he's going to take and submit that to a reviewer. I only set this one up to have a single reviewer, that being the engineer, so it's kind of academic. That's why it's grayed out. So we'll send it back to them, give them a due date when he'd like to be able to respond. We'll submit that, and the RFI has gone out to the reviewer. Now, they would look at an email as well, but by the same token, if I'm in the project, they have the ability that they can look in the project management area of BIM 360. They can see the RFIs and the RFIs that have been associated to them. They can see the documents or the models that have been associated, where it's coming from, in this case, the electrical person. So you can drill into the RFI, get some specifics on what's been requested, drill into the model, see what's specifically being asked, and then respond to the request. So in this case, can see, can the conduit be installed under the head wall? They can review the model, peruse, look around to see anything in the vicinity that might be a problem, determine what the best appropriate answer is, and then submit the official response. So in this case, it's going to be answered, and the response is yes. However, there must be a 3-foot separation between the conduit and the head wall. From there, we see, according to the note, it's been returned back to the manager. The manager can review that and then ultimately can get it back into the hands of the people responsible for the conduit, Evan, so it can continue on through the process and be completed. So from there, once that process is complete, the model has been aggregated and it's ready to go, what we can do is we can deliver that information out to the client. So we'll see what that looks like at the end. In this case, the last person who would have used it is the coordinator. So they've got a folder that has all of that data that will be sent to the client. So they're going to create a transmittal. They'll select the individual who it's going to be sent to. And because they grabbed a folder, it's going to give them access to everything that was in that folder. They can remove or add supplemental documents to the transmittal as well. Say final data for construction. They'll go ahead and send that. The client will receive an email from BIM 360 indicating that Carl has transmitted the final data to their attention. They can go in and view that transmittal. And once the transmittal's been viewed, they can see all of the information that's been sent. So they can start by selecting perhaps a multi-sheet PDF without any authoring application, just using their browser. They're able to view the individual sheets. They can zoom in and see all of the details, same as it was created in the authoring application. If the client requested DWGs or models as part of the submittal without an authoring application, once again, they're able to use the same tool to be able to view the model both in 2D and in 3D, whatever's available for that data. They can, even in the aggregated model, they can drill into that as well to see a completed representation of their project. So once all of that has been reviewed, they have the ability that they can download all of that as a zip file that then they can use for whatever purpose they're going to move to next. Once again, there's a complete transaction log, so once the information's been sent out, anybody who's associated with the project that has access to this can see that it was sent out, when it was received, and when it was downloaded. All right, so we've looked at a number of steps, a number of different ways the BIM 360 tools can be used together to supplement or work on a project like this. As a quick review, let's drill into the different components or the modules that we looked at. First one is Docs. That's our platform. That's our foundation. That's where we stored the documents. We managed position or the permissions. We had the versioning of the different files. We had issue tracking. It helps us in a number of different areas, whether we're in the office, the field, or just doing file exchange. We looked at digital plan review. We can mark up PDFs or the actual design files. We can create issues to track those issues to completion. We got the ability to compare versions, audit trails, even view supplemental models to help facilitate communicating more than just the 2D plan sheets. Provides anytime, anywhere access. We saw where we were able to access it in the field, whether we were doing an inspection or just a quick site visit. We can take measurements, create issues as part of that process as well. And then finally, file exchange. We can create transmittals to send files. We have the large model viewer, doesn't require the authoring application. There are tons of things that provide benefits just out of the core application in BIM 360. In addition to looking at docs, we also took a look at design. Basically in design, the benefit is going to be collaboration. Specifically in collaboration from a Civil 3D perspective, it's going to allow us to host our Civil 3D projects in the cloud. So data shortcuts, file locking, versions, we can do markups and issues. The other module we touched on was BIM 360 Build. Using tools within BIM 360 Build specifically around checklists, we're able to do and help facilitate tools like inspection and doing QA and QC. It's also going to help us with submittals and managing RFIs. If we were to drill into it deeper, we could actually get into tracking performance with daily reports and other things that could help as part of the project. And the last one we touched on was around BIM 360 Coordinate. We didn't use that in its truest sense, that we didn't use that module on the civil side. We kind of supplemented that functionality with Navisworks, and then using a plugin, we were able to create those issues so that we could aggregate model components together and then run some analysis or create a test on that we were able to report back those things that needed to be corrected. So the business benefits for that is going to be around constructability and model aggregation. So we've covered a lot of material in a relatively short period of time. I hope the information was helpful. I also hope you were able to see areas where the BIM 360 platform could provide you value on your civil projects. Let me close by saying thank you so much for your time and attention. I understand your time is valuable, and I appreciate you investing some of that time with me today. See ya.